Hey, good morning, guys. Assalamu alaikum. I apologize for the delay. I'm just having some connectivity issues, but we should be good to go. In 1 minute. Yes, just bear with me for a few more seconds, and then we can start. Okay, so yes, so as you can see in today's lesson, we are going to be starting with calculus. Okay, please do forgive me if there are any network issues, and if anything's unclear, if the screen is unclear or anything, please let me know and I'll try and sort it out. The YouTube chat for it's not it's disabled for some reason, so sorry if you can't type in there. But yeah, just let me know on Zoom if there are any connectivity issues, and then I'll try and sort it out from there. But nevertheless, let's continue, right? So we're going to start off with calculus, okay, which I'm sure many of you have gone through already in the past term. And we'll be starting off with first principle. Okay, so finding the first derivative with first principle methods. Okay, so firstly, okay, first principles has a formula and it looks like this. Okay, we have f prime x. So f prime x, this represents the derivative form of a function. Okay, so if the original function is f of x, okay, the first derivative is f apostrophe s, so f prime x. Okay, we call this the first derivative. This is the first derivative. Okay, and this is the original function. Okay, so just keep that in mind. So in order to solve for the first derivative, okay, in terms with respect to first principle, okay, we have to follow this formula. Okay, so the formula is as follows: f prime x is equal to lim h approaches 0, okay, of f of x plus h, okay, minus f of x divided by h. Okay, and I'm going to do one question with you guys to show you how do we follow this approach. So firstly, it says here, find f prime x, find the first derivative of x by using first principles if f of x is equal to negative 3x squared. So they want us to use first principles, so we're going to use first principles. We've got to write the formula. The formula is f prime x is equal to lim, this lim h approaches 0, we have to write it on each step except the last step. So we have to write that at each and every step, okay, except the last step. Okay, so just keep that in mind. Okay, so we have lim h approaches 0, f of x plus h minus f of x divided by h. Okay, so here we say equals to, I'm going to copy this. Unfortunately, you can't copy and paste in your exam. You're going to have to rewrite it each time. Lim as h approaches 0, the limit as h approaches 0. Okay, so now we want to try and find f of x plus h. Okay, f of x plus h. So sometimes you can do this separately if you'd like, but I'm going to do it all on one step. F of x plus h is really simple. Okay, how do we express this in terms of f of x plus h? Okay, so the normal function here, this here, is f of x. As you can see, it says f of x is equal to negative 3x squared. Okay, so f of x. If I had to say f of a, okay, this would be equal to negative 3a squared. So f of x plus h, so wherever x is, we replace it with a. In this case, wherever x is, we're going to replace it with x plus h. So negative 3x plus h squared, like that. Okay, so wherever we have x in our term, it's like we're substituting x plus h in order to get f of x plus h. So that's the term we're going to write, f of x plus h. Negative 3, wherever x is, we replace it with x plus h. Okay, x of h squared minus, don't forget this f of x. Sometimes when f of x plus h is big, then it's easy to forget f of x plus h, but do not forget f of x plus h. Minus f of x, sorry. Don't forget the minus f of x. So minus f of x. F of x is just the function itself, minus 3x squared, minus 3x squared divided by h. Okay, and this is our first step to this question. Right. Now, again, lum equals, I'm going to paste. Okay, again, you can't paste, sorry. And I have my fraction. I'm going to have to open up this. So I'm going to have negative 3. I'm going to take the shortcut for this, right? So I have to simplify this guy first. Let's get blue back in here. I'm going to have to simplify this, the x plus h squared. So the x plus h squared will become x squared plus 2xh, okay, plus h squared. So what I did was I just did the binomial by binomial, okay, the shortcut method. So it's basically just foiling it out. So if you want to take that step by step, you'd foil it out. Okay, and here I have minus 3x squared divided by h. Now I'm going to paste again. Let me copy with the fraction. That would be nice. With the equal to sign, with the fraction. So we can take a massive shortcut. Oh no. Okay. And now I can open up my brackets. I have negative 3x squared, negative 6xh, negative 3h squared, okay, minus 3x squared divided by h. So normally what you are expecting actually is for some things to cancel. What you are expecting are for some things to cancel. So right here we have, what's going on? Sorry, this is supposed to be minus 3. When we substitute f of x is negative 3x squared itself. So it's supposed to be minus, which is supposed to in fact give us a plus. Okay, so f of x is actually negative 3x squared. So it should be minus, and that becomes plus, and this becomes plus as well. Okay, so now, like I was saying, when you get to this step, you want to actually expect certain things to cancel. So this, for example, negative 3x squared and positive 3x squared, that becomes 0. So they'll cancel each other out. Okay, and please always expect something to cancel. And if nothing is canceling, perhaps you did something wrong and you need to go and check it out. Okay, you need to go back and see maybe you did a step wrong or something like that. Okay, so those two cancel. Right now, for the final step, not for the final step, but the last time we write lum as h approaches 0, what we are going to do, again, always is take a common factor. So when you take a common factor, so you want to take a common factor on top of h. Don't take it of negative 3h or 3h. Even if you can take other factors, just take h. Okay, because you want to cancel it with the h here at the bottom. That's ultimately our objective. Okay, so you're going to take a common factor of h. On top, what do I have? I'm left with negative 6x minus 3h divided by h. 1 and 2 cancels. Okay, now what you can do is this is now the second last step. In the final step, once you've canceled h, that is when you want to now substitute h as 0. So you're taking the limit as h approaches 0, okay? And the whole time we were just simplifying this, simplifying it until we got to here, the final simplified step, okay? And once we've reached that, once we've taken our common factor of h, essentially, we are going to substitute h as 0. So you don't have to put lum. So I'm just going to say equals to. So this could be on the next line as well. It's fine. It's just that I'm writing it here. I don't have space. Okay, is equal to negative 6x minus 3 into 0. And what does that simplify to? Negative 6x. And whatever this simplifies to is the final answer. This is the first derivative of our function. Our function is negative 3x squared, and its derivative is negative 6x. Okay, using first principles, that's how we determine the first derivative of a function. Okay, so again, f of x plus h, wherever you see x, you're going to replace it with x plus h. So that's exactly what we did. We subtracted f of x, so minus 3x squared, right? And then we just simplify. So we multiply out the binomial by doing FOIL, okay? And then we multiply the -3 into it. We canceled some terms. We took the common factor of h and we simplified, and then we substituted h as 0. So you'll see all of them follow a common, like they all do a similar thing. Now let's talk about deriving without using first principles, okay? Just basic deriving on a term. So it says here, if f of x is equal to axb, we're looking on the first line. If f of x is equal to ax to the power of b, then first derivative of x is equal to b times a to the power of x, a times x to the power of b minus 1. So what we do, okay, is if we look at this example here, f of x is equal to 3x squared. What we always do is we take this exponent of our variable, we multiply it by the coefficient, so 2 times 3, and then we subtract 1 from the exponent. So we take the current exponent, we multiply it by the current coefficient, okay, and we subtract 1 from the exponent. So if f of x is equal to 3x squared, okay, then let's make this negative so it's uniform with that other question. If f of x is equal to negative 3x squared, then f prime x is equal to 2 times negative 3, which becomes negative 6, x to the power of 2 minus 1, x to the power of 1, which is basically negative 6x. Okay, so when we solve using first principles, we have to do this long method, right? And it's easy. It's just substitution into a formula. Okay, and yeah, they'll tell you using first principles. So obviously you'll then use first principles, right? But first principles, there is no way you should get first principles wrong because it's easy. You're just subbing it into a formula, number one. Number two is you can always check your final answer. How do you do that? So you use it, you solve it using first principles, using the formula, you get an answer. Then what you can do is just derive the actual term, like how you would normally derive. Multiply exponent by coefficient, subtract 1 from the exponent. This would become negative 6x to the 2 minus 1, which is 1, which becomes negative 6x. So here, this definitely should be your answer. This is the first derivative of negative 6x squared. And using first principles, you got the same method as well. Sorry, you got the same answer. So you know 100% your answer is correct. So that's why you should never get first principles incorrect, because you can easily check your answer. And if it's not the same, then you know that maybe your first principles is incorrect. Okay, so just keep that in mind. Okay, so let's look at the next example using first principles. Okay, so find f prime x by using first principles if f of x is equal to 4 minus 5x squared. If f of x is equal to 4 minus 5x squared. So here's our formula written for us. We can now just, this is incorrect formula. Lim. As h approaches 0. Okay, let's steal that. Let's copy it over to the next line. Okay, so now we're going to substitute. We're going to do it where we do f of x plus h separately. Okay, so I'm going to do this, and I'm going to solve f of x. This is another option if you'd like, just to solve it separately and then put it into the formula. Okay, so f of x plus h is equal to 4. Don't forget that 4, right? So 4 minus 5x squared is the function. So that's f of x. So f of x plus h is going to be 4 minus 5, open brackets, x plus h squared. Okay, so we can choose to simplify this first. So 4 minus 5 into, I'm going to do FOIL, the shortcut, plus 2xh plus h squared, which is equal to 4 minus 5x squared minus 10xh minus 5h squared. So now what I've done is I found the value of f of x plus h, right? F of x plus h is equal to this. So I can now just plug it into my equation, okay? So let's work here. Okay, so now what I can say is lim, let's do that. The limit as h approaches 0 is f of x plus h minus f of x. I know the value of f of x plus h. I simplified it separately just to make things less complicated on your current fraction. That's why you can opt to simplify it separately. Minus 10xh minus 5h squared. Okay, now I need to say minus f of x. Okay, because this here is what? This here is f of x plus h. Okay, f of x plus h, f of x plus h. That's f of x plus h. All of it is f of x plus h. Now I need to get this guy. Okay, f of x minus f of x. So I'm going to say minus, and because this has more than one term, I'm going to use brackets. Minus 4 minus 5x squared, just minus f of x. Okay, so you just minus the function itself. Okay, divided by h. Then we paste. We have to write lim as h approaches 0 at each and every step. Okay, let's look above here. Okay, okay, let's just open up this and then we can cancel. 4 minus 5x squared minus 10x h. Again, you don't have to write every single step. If you can skip some steps, you may. No, I'm writing 10, but it's fine. So this should become minus 4 plus 5x squared divided by h. Okay, then again we paste. Right, now if we look on top, right, again we're expecting things to cancel, always expect things to cancel, and that's when we look, we have positive 4, negative 4 cancel with each other. Negative x 5x squared, positive 5x squared, they become 0, they cancel with each other. I'm left with this. So now this is where I'm going to take my common factor of h. When I take my common factor of h, I am left with negative 10x, okay, minus 5h. Negative 10x minus 5h. I took a common factor of h, okay? Then I have h at the bottom still. That's from the formula. H and h cancels. Now what I can do is substitute 0 for h. So I ignore the limit. This is the final step where I do not write lim as h approaches 0. I just substitute h as 0. So it's like when you substitute it, you get rid of it, right? Negative 10x minus 5 into 0. And that gives me my first derivative function as negative 10x. This is my first derivative function as the final answer. Okay, so first derivative function can be solved using first principles method. Okay, so just keep that in mind. So remember, we can always check our answer, right? So when it comes to this, okay, we can check our answer. So we didn't learn it yet. We'll go through it on the next page, but when we derive a constant, okay, the deriving a constant, it results in 0. So we ignore this. Again, we'll discuss this more on the next page. So we just have to derive that. So exponent times coefficient and exponent minus 1. So it becomes negative 10x to the power of 1, which is just negative 10x. So we've proven that both answers are the same. We've checked our answers, so we know definitely our first principles equation is correct. Okay, let's move on to the final practice and example of first principles. So we have this correct formula, and this is the function negative 4 over x. Okay, this is slightly more complicated. That's how I'm going to do it. Okay, so I'm going to solve it in one step. So this is going to become negative 4 over x plus h, because that's what f of x plus h is. Wherever x is, we put x plus h minus f of x minus 4 over x. Sorry, 1 second, I apologize. Okay, so f of x plus h is negative 4 over x plus h minus 4 over x divided by h. Okay, so now we have to simplify this. We have a complicated fraction. So we have to do LCD. So the LCD is going to be, let's maybe give us some space. The LCD is going to be x into x plus h. Okay, because we multiply these two denominators. Whatever's missing from this side is x. So this is going to become negative 4x. Okay, and it's minus minus, so it becomes plus 4 into x plus h. Okay, all divided by h. So now I can tip in times. Again, at each and every step, I have to write lim. Okay, so this becomes negative 4x plus, I'm going to simplify this, 4x plus 4h divided by x. This denominator we don't have to open up because essentially we're going to have the same thing. Okay, times. So remember, when you tip in times, because this is division of fractions, h can be written as a fraction, h over 1. Okay, so it becomes 1 over h multiplied by 1 over h. Okay, so now again we still write limit. We haven't substituted that as 0 yet. Here we have negative 4 cancelling with positive 4. Okay, and we can cancel this h, because now once we cancel this, right, it's like it didn't exist, and we just left with 4h. So now it's like 4h, it's just on singular term. There's no plus stopping us from canceling. So we can cross cancel this h with that h, and we are finally left with 4 over x into x plus h. And this is now where we can substitute h as 0. So we can say equals to 4 over x into x plus 0, which becomes 4 over x squared is our final answer. Okay, so that is indeed the correct final answer. This is the first derivative function of f of x. Okay, we can confirm that answer, and I'll show you how we're going to confirm that answer by just deriving it. Okay, so another rule of deriving, you'll see it's called a differentiation rule, is that we cannot derive something that's in the denominator. So what we do to simplify this is we take it to the top. Okay, we'll go through this on the next page. So this actually should become negative 4x to the power of negative 1. Okay, x to the power of negative 1, because whenever we take an exponent to the top, we change its signs. Okay, we'll go through that properly on the next page. And then this is essentially what we're deriving. So this becomes positive 4, because negative 1 times 4, positive 4x to the power of negative 2, because it's negative 1 minus 1. So if they want us to write it with positive exponents, we can take this to the bottom again, and it becomes positive 2. So 4 over x squared. So here we get 4 over x squared when we derive this way. Here we get 4 over x squared when we derive using first principles. So we know for sure our answer is correct. Okay, so just to keep in mind, you can always, what you might call it, you can always double check your answer, just deriving normally. Okay, so those are 3 solid examples of first principles. I hope that you guys understand. Let us move on to some differentiation rules. Okay, so just keep in mind this. Okay, when we derive, this is how we derive. Let's take it over here. So the differentiation rules apply for this, right? Let's maybe get rid of this. Oops. Okay, so the ones that are highlighted, we're going to go through first, okay, because those are the main differentiation rules. Okay, so we'll go through those first, and then the others we'll go through afterwards. They are just other certain rules that we need to follow, that we need to understand in order to derive. So let's go through the differentiation rules first. So basically, what are the differentiation rules? Differentiate, because we cannot derive every term immediately. Okay, there are certain criteria that we need to have for a certain equation in order for us to derive. Okay, and if they do not meet that criteria, then we differentiate, right? You'll see it will make more sense once we learn the rules of differentiation, once we learn how to differentiate. So rule number 1 says the derivative of a constant term is equal to 0. Is that the differentiation? Okay, yeah, it's fine. Yeah, pretty sure it's one of the differentiation. It's fine. If it's not, I'll go unhighlight it and it doesn't really matter, right? Either way, you need to know all of these rules. So derivative of a constant term is equal to 0. So if we have f of x, right, is equal to 5, then the first derivative doesn't exist. Okay, this is equal to 0 because the derivative of a constant is equal to 0. So let's look at this one here. What if we have f of x is equal to 3x squared minus 3? How do we derive this? Okay, this follows another rule. Actually, we must derive it separately. If we have 2 or more terms, we must derive it separately. However, so let's derive the first term. The first term we can derive 2 times 3. So f prime x is equal to 6x because 2 times 3 is 6. X to the power of 2 minus 1 is x to the power of 1 minus 0. Because this is a constant, negative 3. So this is equal to 6x. Okay, so just keep that in mind. So let's quickly go through rule number 2. I know I said I will go through the highlighted ones, but rule number 2 is important before we carry on. So if there are 2 or more terms, derive the terms separately. If there are 2 or more terms, derive the terms separately. So for example, in this case, we have 3x to the minus 1 plus half x6. So all we have to do is derive this guy, then derive that guy. Okay, so this becomes the first derivative becomes exponent times coefficient, negative 3, x to the power of negative 2 plus 6 times a half, exponent times coefficient, which is 3, x to the power of exponent minus 1, 6 minus 1 is 5. So that's our first derivative. And if we want only positive exponents, we can take this guy to the bottom by changing its exponent. So negative 3 divided by x squared plus 3x 5. Okay, so let's just write this a bit neater. That's our final answer here for the derivative of 2 different terms. Okay, right. Let's look at the second differentiation rule. X cannot be in a surd. X cannot be in a surd. So the first one was the derivative of a constant term is equal to 0. Now we're having, this is another rule, x cannot be in a surd. So if we're deriving, if we want to find the first derivative of an equation and x is in a surd, we cannot have that. We have to take it outside of the surd. So how do we do that? Let's have a look at this example. How do you take something out of a surd? By creating a fractional exponent. A fractional exponent, just a fancy word to say that there's a fraction inside of the exponent. Okay, so when we have the b root, however you say that, of x to the power of a, what happens is you can take it out, write the base inside of the surd as a base outside of the surd, okay, and put it to the power of, make the power, the numerator of the power, the exponent inside, and the denominator of the power, the number that you're taking the root of outside of the surd. So for example, if I had the square root of x, right? So the square root of x, we normally just write square root of x. But if we have to actually consider what are the powers that are here, we have x to the power of 1, that doesn't change the value, and it's the square root of x to the power of 1, okay? This is equal to x to the power of whatever's inside, numerator, whatever's outside, denominator, is equal to x to the power of a half. And this is actually something you should always remember, that the square root of x is equal to x to the power of a half. Okay, so let's quickly look at another example of that. Let's just say we had the fourth root of x to the power of 3. This would become x to the power of 3 over 4. Okay, so that's how we take something out of a surd. All right, that's fairly simple. So let's have a look at this. If example, if f of x is equal to -3, x to the power of -4, so in this case, x is inside of a surd, that cannot happen. So we have to take it out of the surd by creating a fractional exponent. This would become, keep the base the same. Okay. By the way, this -3 is actually multiplying the surd. So we'll just say -3 times. So by the way, sorry, I have not derived yet. Okay, I'm just differentiating. That's what this is called. I'm just differentiating. Okay, I haven't actually derived yet. So that's why I cannot write the first derivative, right? I'm just differentiating and then I'll derive afterwards. So I'm still working with f of x, right? I'm just changing the way that this term is expressed. So this power here would be a 2 whenever it's not, whenever there's no, whenever there's nothing, whenever there's no number outside of the set, it's always the square root, right? So it's the square root of x to the power of -4, which becomes the -3 times x to the power of -4 over 2, which is essentially -2. Okay, now we can derive. So the first derivative of this is equal to, this is -4 over 2 is essentially -2. -2 times -3 actually becomes +6. +6 to the power of x, -2 minus 1 becomes -3. Okay, I hope you guys are following along and this makes sense. So the first derivative of -3, let me check my answers as we go along. Yeah. First derivative of -3 square root of x to the -4 is 6 to the x minus 3. So we have to differentiate. Why? Because x cannot be in a surd. X cannot be in a surd, so we take it out and we write it as a fractional exponent, and then we derive exponent times coefficient, and 1 minus, you subtract 1 from the exponent. Okay, let's look at the next differentiation rule. X cannot be in the denominator. So what do? We have to take it to the numerator, of course, right? So x cannot be in the denominator. So this one actually involves two, x being a surd and x being in the denominator. So if f of x is equal to 3 over the square root of x to the power of 5, what is the first derivative of x? So firstly, I'm going to differentiate according to the thing we learned in the previous step. We cannot have x in a surd. So while it's in the denominator, I'm going to take it out of the surd. So this becomes 3 over x to the power of 5 over 2. X to the power of 5 over 2. Okay. Let's find space for that. 3 over x to the power of 5 over 2. So now we've done one type of differentiation. We've taken it out of the surd. However, we still have to do another because x is in the denominator. It cannot be in the denominator, so we need to take it out of the denominator. So how do you take it out of the denominator? This is where your negative exponents come in, okay? So if x is in the denominator and it's positive, if you want to take it to the numerator, you'll make it negative. So if you want to take it from denominator to numerator, or numerator to denominator, all you have to do is change the sign. So in this case, it's in the denominator and it's positive. So when I can take it to the numerator, I just have to make the exponent negative. So this becomes 3 times x to the power of -5. That's right. -5 over 2. Okay, this becomes 3 times x to the power of -5 over 2. So let's do some examples just to clarify that. If I had x to the power of -6 over x to the power of, no, let's do this, y to the power of 7. If I want to swap both of them, this would be equal to, I can take the 7 to the top, it would become -7, and I can take this -6 to the bottom, it would become +6. Okay, so you just can swap the sign. Okay, so now this is derivable, however you want to say it, because I've differentiated properly, right? There's no x in a surd. Okay, there's no x in the denominator, so now I can derive it. So f of first derivative of x, f prime x, exponent times coefficient. So let's do exponent times coefficient, which is basically -5 over 2 times 3, exponent times coefficient. That's going to give us -15 over 2, okay? And then x times x to the power of negative 5 over 2 minus 1. Negative 5 over 2 minus 1, that's actually negative 7 over 2 to the power of negative 7 over 2. So it becomes negative 15 over 2 times x to the power of negative 7 over 2. This is the first derivative of the function. Okay. Hope that makes sense. Right, so x cannot be in the denominator, nor can x be a third. So that's how we derived it. Let's look at the final differentiation rule. Rule number 5, if there are multiple, x cannot be in multiplication form with another x. So what do you have to do? You have to open up the brackets. So in this case, let's have a look at it. F of x is equal to negative x squared multiplied by 2x plus 1. Do you see this multiplication form? We do not want that. We do not want it. We always open up and simplify the brackets. Okay, so we simplify this. So f of x is equal to, now how do we multiply this? This is just simple distribution, right? Simple distribution, we just multiply it into each term. Okay, so this becomes negative 2x cubed minus x squared. Negative 2x cubed minus x squared. So now x is no longer in multiplication. We can easily find f prime x, or the first derivative of x. It is equal to negative 6x squared, because I took the 3, multiplied it by the negative 2, and said 3 minus 1, which is 2. And this becomes negative 2x, 2 minus 1 is just 1. And this is the first derivative of my term. Okay, I hope that makes sense. Okay, so that's how we find, that's the rule we follow, that x cannot be in multiplication form with another x. Let's have a look at rule number 6. Rule number 6 says, if there are multiple terms in the numerator above one denominator, write each term separately with the denominator. So if there are multiple terms in the numerator above a single denominator, write each term separately with the denominator. So we can separate each term with respect to the denominator. So what the example of what that explains is this, okay? Multiple terms in the numerator above one denominator. So we need to write it separately. So let's see how we do that. So this here, we just have to write f of x is equal to 4x to the power of 5 divided by 2x, keep the sign the same, minus 6x4 divided by 2x plus 3x over 2x. Okay, 4x5, we just write them separately with the denominator. 4x5 divided by 2x minus 6x4 divided by 2x plus 3x divided by 2x. Okay, and now before we even derive, we can simplify. So let us simplify, right? We can simplify this. Simplifying it, this x makes that 4, this x makes that 3, and these x's cancel. 4 divided by 2, that's 2x to the power of 4. 6 divided by 2, that's 3x to the power of 3 plus 3 over 2. So now we have multiple terms. We derive each term separately. So here we can find f prime x. So f prime x is equal to 4 times 2 is 8. X to the power of 4 minus 1 is 3. 3 times negative 3 is negative 9. X to the power of 3 minus 1 is 2 plus 3 over 2. How do we derive a constant? The derivative of a constant is equal to 0. So essentially that's plus 0, or we can just ignore it. And that's our final answer for the first derivative of x. Okay, so these are just extra rules that will help you, right? They're not exactly differentiation, but these are extra rules. Let's look at the last one. If there are 2 or more terms in the denominator, if there are 2 or more terms in the denominator, factorize, then simplify before deriving. Okay, so this one is important, right? If there are 2 or more terms in the denominator, factorize, So now we two or more terms in the denominator. In the previous one, there was a single term in the denominator. Now we're talking about two or more terms in the denominator. Factorize and then simplify before deriving. So let's try and factorize. So we can factorize the top and we can factorize the bottom, right? So before we derive, we need to factorize. So the top is a trinomial, so I can simply open up two brackets and factorize in that manner, right? So x squared minus 3x minus 4, okay? So I have x minus x plus, okay, minus 4 plus 1. And here I can factor out 2. This becomes x minus 4. So now I can cancel, okay? I can cancel this guy and I can cancel that guy. And I am left with f of x is equal to x plus 1 over 2. Okay, x plus 1 over 2. Now what I can do is I am in rule number 6 again, okay, where I have multiple terms in the numerator and a single term in the denominator. I can split it. So I can write this as x over 2 plus 1 over 2. X over 2 plus 1 over 2, okay, which is essentially 1 over 2x, if you want to write it. So we always should try and write it in terms of a coefficient and an exponent. 1 over 2x plus 1 over 2. Okay, and now to find the first derivative, okay, I just need to remember that's a constant, so it will be 0. This is to the power of 1, so 1 times a half, and then x minus 1, which is 0, which is 1, so it's just a half. Okay, the first derivative function is just 1 over 2. So just this is a rule here also to remember. If f of x is equal to a to the power of x minus 1, then f prime x is just a. Okay, it's just the coefficient. If you have a term where the exponent is 1, then your derivative is just the first term. Okay. Okay, cool. So those are the different rules of differentiation, as well as some other rules just to help you to simplify terms before you derive them. Okay, before they get tough. Okay, so let us end it there. And when we continue with our next lesson, we will continue with some notations and deriving different terms in terms, excuse me, different terms in terms of different variables. So yeah, thank you guys so much for joining. I shall see you guys in the next lesson. Okay, Jazakallah khair. Assalamu alaikum and good